I use machine learning to differentiate between muffins and chihuahuas. You might think that sounds lame, but have you seen some of these pictures on the internet? Sometimes it's pretty hard to tell the difference between them. I coded this up and it was actually surprisingly easy. There's 4 things that we're going to need to do. We need to gather our data, prepare the data for machine learning, train our model, and then we need to productionize our model, which means putting it out into the internet so we can use it from anywhere. You never know when you're going to be walking down the street and you need to know the difference between a chihuahua and a muffin. So let's walk through my code and see how I did it. In order to do this, I used the fast.ai library, which you can see I'm importing here, Fastbook, that's the package they provide. And then I'm importing some other sub packages that they used, which I'll use later. I've decided to use the Bing image downloader to download the images from the internet. So you can see here, I've imported the package, and here is where I'm downloading the images of Blueberry Muffins and Chihuahuas. So let's run this code. Now that we've got the data downloaded, let's show one of the pictures. So here is a Chihuahua, and here is a Blueberry Muffin. Now let's just get the file paths to all the images we've downloaded. Alright, so the pictures look good, and that's it for step 1. We've gathered the data. Now we need to move on to step 2, preparing our data for machine learning. So the fastai library provides 2 data structures that are going to be useful for this step. The first is data blocks, and the second is data loaders. A data block is basically a representation of your data on your computer. You need to tell it where your data is, how to label the data, and what type of data it is. In this case, it's images. And then a data loader feeds data to our machine learning algorithm. So let's create those. And now let's look at a batch of data. Awesome. That looks pretty good, but there's one more thing I want to do before we start with the machine learning. I want to take our data and create more of it by taking each picture and randomly resizing it and cropping it in different ways. So fastai provides this tool called random resize crop, which will do exactly that. Let's run it and let's show a new batch. And now you can see that the single picture has been randomly resized and cropped in different ways and shapes. And it has done this for all of the pictures of muffins and chihuahuas. So now we have much more data to train our machine learning model. And that's it for step 2. Now let's move on to step 3, training our machine learning algorithm and creating the model. So for this step, I'm going to use transfer learning. That's where you take a pre-trained model and then you tweak it to fit your specific use case. So here, I'm going to use fastai's Vision Learner with the ResNet 18 neural network architecture. This has been pre-trained on thousands of images to classify a bunch of different objects, but I'm going to tweak it to specifically classify between muffins and chihuahuas. And all you have to do is to create the Vision Learner and then run fine-tune. So let's run that now. And one more thing to note, here it's called fine-tune instead of train because we're just fine-tuning it, adjusting it, instead of training it from scratch. Now it's finished training, and you can see here the train loss or the training error keeps decreasing, and so does the validation loss. If the validation loss were to start increasing, then you know we'd have overfitting and we'd have to go back and adjust things. But everything looks good here, so that means we've finished step 3, and we can move on to step 4, which is productionizing the model. Now, in order to export our model, all we need to do is call the fastai's export function, which you can see here. Let's run that. And this has now created the export.pickle file. Pickle is a Python package that allows you to export data structures and objects to files, just like we've done here. So now that we've got it exported, we can upload this to a Hugging Face space. Hugging Face is an AI company that provides these spaces that allow us to store our models online for free. So I'm going to upload our model there, but first we don't want to just upload the model. We want to have a user interface for it. And in order to build that user interface, I'm going to use the Python package called grad.io. In order to get grad.io working, we need a couple things. We need to load our model. We need to define a predict function, which I've done here. You can see it takes in an image and then just calls our model's predict method and returns the results. And then we just need to specify some things for the Hugging Face space. like a title and description and maybe some examples of images for it to give the model to classify. And the last step is to call the Grad.io's launch function, which creates the interface. Now, once we push this file to the Hugging Face space, it already knows how to interpret these Grad.io files, so it'll take care of that for us. I've already done this the other day. Now let's go check it out. So here's our Hugging Face space with our Chihuahua versus Blueberry Muffin classifier. And if you scroll down, you can see some of the images I provided. So let's select one of them and see how our model does. All right, so our model thinks that this is definitely a Chihuahua. 100% Chihuahua, 0% Blueberry Muffin. Let's try the next one. Same thing, same thing. Oh, this one thinks it's 1% Chihuahua. Let's try the next one. 7% Chihuahua. Try this one. Oh wow, this is awful. So we probably have to go back and train our model a little bit longer so we can give it a better score here. And let's look at the last one. And this one's not so bad. And that's it. If you like this content, please be sure to check out the video I put on the screen and to like and subscribe. I've also put more links to other videos in the description below for your continued learning.